Given that f of x equals log of x, sketch the graphs of y equals f of x and y equals minus f of x plus 1 on the same diagram. Label the coordinates of the points of intersection with the x-axis and indicate the behavior of the graphs for large positive and negative values of y. So I've got the summary of the question here. So I'm just going to do a little sketch by hand, although your sketch would need to use a ruler. And I'm going to use dashed lines for the actual plots. So here's my axis, and I'm going to do a dashed line because it's easier to draw a dashed line with a digital pen. So apologies that they are dashed lines. So here's the x and y axes first of all then. Okay, so we want to plot the log function. Now the log function is not defined for x negative, it's only defined for x positive, and we know the log of 1 is 0. So here's the point 1. And we know that it comes up here. It's like the exponential turned around from the x to the y axis, turned around on itself. There we are. It's just like the exponential if you imagine this was the y and this was the x, and the graph twisted over and put back down. So here's the x-axis, here's the y. It's a standard function, and this is the log function, so let's label that. Fx equals ln x. So there's our log function. Log 1 is 0, and there's how it tends to, continues to increase to infinity, doesn't it? But this curve goes up more and more gradually, and it shoots down to minus infinity here. So where it cuts the x-axis, we've done that, and indicated behavior for large positive and negative y values. I think it goes down there to minus infinity, so I'm going to just label and indicate the behavior. So it tends to, here it tends to minus infinity as x gets closer and closer to 0. Okay, so that's what happens there. Negative values of y, so that was that one. Now we want minus fx plus 1, so let's have a go at sketching that. So I'm going to fx plus 1 first of all, let's sketch that. So if I think of log, I'm going to need to write fx plus 1 first of all. That's the easiest thing to sketch. Will be log, x is log of something, and the something is x plus 1. So the log of x plus 1 then, if I put 0 in here, so the input of 0, the output would be log of 1, wouldn't it? Which would be the value here. So that point is as though it were transferred over here. So instead of it going down at 0, it goes down at minus 1. So I'm going to draw an asymptote here now, because instead of shooting off to minus infinity just above 0 here, because this is moved back 1 as we just said, then it's going to shoot off to the asymptote down there, isn't it? So this graph I'm drawing now is none other than log of x plus 1. There it is. Okay, so there's our graph log of x plus 1 here. But we don't want that, do we? We want minus, so I'm going to choose another colour now. And we'll do the minus. So these positive values will flip around, so it's reflected through this x-axis, isn't it? So it comes up here, like so. And it's the mirror image, so to speak, through the x-axis. So it goes through there, and then it comes around and goes along here. Oops, that writing's slightly in the way, isn't it? There we go. So it tends to, so this is y equals minus fx plus 1, and as x tends to the value minus 1 from above, positive side, y tends to shoots up to infinity, doesn't it? Okay, and that's where it tends to, and then it just continues to decrease here. So this was the graph, as we've just said. So this would be log minus log of x plus 1, if we want to write it explicitly.